Okay, so problem 5. So problem 5 is a bit of a tricky one. So problem 5 asks, what direction is acceleration at point y? So when this pendulum is at point y, where is it accelerating? So let's just take a look at this thing here. We have 1, 2, 3, or 4. So this is interesting, but there's a lot of there's a lot of options that could kind of be the answer, or like I could see them being the answer. So let's start by eliminating obviously wrong ones. So it cannot be 2 or 4. The reason for that is that there's no net force there's no force pushing them to go in either of these directions, because the only force that is being acted upon or acting upon this ball right now is tension from the rope and gravity. So it cannot be 2 or 4. That leaves us with 1 and 3 and, well, E. Now, here's the thing. If the ball had a greater gravitational force than tension force, then the ball would just start falling. There would not be a pendulum. So it cannot be 3 either. Now that leaves us with A and E. Now, here's the thing. When a ball is at this point, at the very bottom point, it kind of exhibits something like a circular motion force, where when you're here, you kind of require a centripetal force, or a net force upwards, or in other words, an imbalance in force for the tension. So the tension force is greater than the gravitational force. So Ft is greater than the gravitational force in order for the thing to keep moving with constant acceleration upwards. So basically, there is going to be a greater force going upwards compared to the gravitational force in order for this thing to exhibit the circular motion, and hence it must be 1, because there's a net force going upwards. And it can't be E either, because, well, there's a net force going upwards. So yeah, it's a bit of a tricky question, but you have to be able to recognize that at the very bottom of a pendulum, circular motion is exhibited. Okay, I'll see you in the next video.